Hello everyone. In this lecture we are going to see a new data structure called graph. Okay, so before getting into graph, I hope you already knew about tree data structure. Okay, so we will take one revision about it. Uh, we already knew that tree is a special type of graph. Tree is also a graph. Okay, tree is also a graph, but it's some kind of special type of graph. Why it is special type of graph? Because it holds some properties. So when you take one graph, okay, and you put this property into it, okay, then it will automatically become tree. You take one graph, you put this property, then that graph automatically become tree. Okay, so what is the property? First of all, that graph should be hierarchical in structure. Okay, we understood that hierarchical in structure. You can see here in example A, B, C, D, E. These are all nodes and vertices, right? These are all called nodes. Now A is related to B, right? And A is related to C. That means A is a parent and B and C both are child of them, right? So you can see that hierarchical structure is that parents and son. For example, how is A related to D and E? So A is a grandfather, okay, of D and E. So that hierarchical structure is maintained, right? So both are, this B and C both are child. So that is Ray. Okay, now coming to root node. Tree should always have a root node. Okay, for example, here in this case, this is a root. Okay, for tree. So this is there for tree data structure, and there should be no cycle in a tree. Okay, so when there is a graph, if you maintain that there would be no cycle, then definitely, can you see any cycle here? What is the meaning of cycle? Cycle means if A is related to B, okay, and is related to D, then D is also related to A. You can see the clear cycle here, right? It's forming a cycle. Oh, so this thing is not possible in tree. There will be no cycle. Okay, right? A is related to B, then B is also related to B. This is not possible in tree. Okay, so there is no cycle. Has only one path or edge between two nodes. Okay, this is also very important. What is the meaning of this is you can clearly see one thing, that from A to B, for example, A is my source and D is my destination. Okay, now I want to reach from A to B, A to D, sorry, right? Now how can I reach? Is there any different paths? You can see there will be always a unique path in tree. For example, if I want to reach to D, then from A to B, then from B to D. That's it. From A to B, then B to D. Can I reach to D from different path? For example, if I try to go from A to C, can I reach from C to D? No, this is not possible. Then there would be a cycle, right? So this is not a tree. Or if I try to reach from A to B and from B to E, can I reach from E to D? No. So you can clearly see that there is only one unique path to reach from A to D. So that is what the meaning of only one path or edge will be between two nodes, any two nodes. Okay, every child has only one parent. You can see B and C are the child of A and both have only one parent. Here also both have only one parent. You take any tree, this property will hold. Exactly n minus 1 edges for n nodes. Okay, this is important. So you tell me how many number of nodes are here? 1, 2, 3. You can clearly see, right? 1, 2, 3, 4, 5. So we have n equal to 5 nodes, right? Now how many number of edges are there? 1, 2, 3, 4. So number of edges is how much? So that is what they are talking about. Edge is n minus 1, which is 5 minus 1, that is 4. So we have 4 edges, right? This property will always hold to any tree. You take any example of tree, it will always hold these properties, that if there would be n nodes, then exactly n minus 1 edges will be there. If you want to see, I will take one more example. Okay, take this particular example. This is a tree, right? How many number of nodes are here? 1, 2, 3, 4, 5, 6, 7. So we have 7 nodes. Then how many number of edges should be there? It should be 7 minus 1, which is 6. Right? 6 edges should be there. Is it possible? Let's count it. 1, 2, 3, 4, 5, 6. Yeah, 6 edges. You take any example of a tree, you will find the same thing. Okay, so if the graph follows all these properties, okay, then that graph is called special type of graph, and that is called tree. Right, now we will see what is graph is. We will see the definition of graph. You understood tree. Now we will see the definition of graph. So you can see structure is simple and organized. This structure would be very simple and organized. Now this is a definition of graph. Okay, now you can see the definition. The graph is a data structure. What kind of data structure? It's a non-linear data structure. Okay, it's not a linear data structure. Okay, tree and graph both are non-linear data structure. Linear data structures are linked list, okay, array. They all are linear data structure that consist of nodes which connects them. Okay, this is a simple definition. You try to understand this definition right now. This is one of the mathematical definition because it consists of a set of vertices and set of edges. I am coming to this definition later. Okay, just understand this part. Okay, what does it mean is, you can see it connects nodes and edges which connect them. So what is node here? See this round circle, na? These all are called nodes, or one more name for it is vertices. Okay, I will write here. One more name for it is vertices. Okay, so all these circles are called vertices, and you can see the clear here. This is called edges. All these lines, sorry, this not this one. This all these lines are edges. Okay, fine. Now what does it defines? You can understand one thing. See, this particular node can define any object. Okay, it can represent any object. Okay, any entity. Okay, like a person, okay, place, okay, anything, I don't know, etc. Right, and this particular edges can define a relation, okay, or a relationship between whom? Relationship between any two edges, sorry, any two nodes. Relationship between any two nodes. Okay, so that is the representation of this particular edge. Okay, this edge. Fine. Okay, so if you want to understand that, you can understand. For example, I told you that this object, this can represent any object. For example, this one is a person and three is a person. Okay, so one is, this line represent one is a friend of 3, and this line can even represent the 3 is also a friend of 1. Okay, so friendship will be in both the side, right? One is only friend of 3, that is not possible, right? So this is the thing. So it represents the relation. Okay, so that is one. If it is a place, then it can represent, like for example, it is Delhi and it is Bangalore. Then from Delhi to Bangalore, what is the distance? That can be related. Okay, and from from Bangalore to Delhi, what would be the distance? So that can be represented. So it can represent the pathway also. So that kind of thing. I'm coming to that point. Okay, don't worry. So it's just an overview so that you can understand about the graph. Now I'm coming to this definition later. This is a mathematical definition. So I have to explain few more topics, then you will understand it in a better way, right? Okay, now we will understand something called directed and undirected graph. So graph can be classified on whether the edges have direction or not. So based on whether the edges have direction or not, on the basis of that you have two classification of graph. That is, one is directed, undirected and directed graph. Okay, so this is the example. You can see this is example of undirected graph. Okay, so what is the definition of undirected graph is? It's a graph in which edges do not have any direction. See, what do you mean by that? Edges do not have any direction. So you can see like this. For example, I written there the connection between two vertices works in both the way. That means, for example, if there is a direction, then what will happen? I will represent like this. This is called direction. Okay, this okay, that means A is connected to B, but B is not connected to A. Okay, if there is a direction I'm talking, but if I'm not giving this direction, then what is the meaning of this? A is connected to B, okay, but B is also connected to A, so both the way connection is there, right? But if I put the direction like this, then that means A is connected to B, but B is not connected to A. Or if it is a place, then what you can say that from A to B I can go, but from B to A I can't go, right? Or you can say one more way that A is related to B, but B is not related to A. Okay, if there is a direction. But if there is no direction, then A is related to B, B is also related to A. Or A can go to B, then B can also come to A place, right? If it is a place. So that is what written here. It's a connection between two vertices works in both the ways. Now the vertex A is connected to B, then B is also the same thing what I said, right? Now if you want to represent, and this is how, this is what is the meaning of this? This is what I written here. That means you can write U and V is a vertexes here, right? So that means if A is connected to B, okay, if A is related to B, then B is also related to A. So if you want to represent, this is the way you are representing. Or another way to say is if A is related to B, that means if A is related to B, then B is also related to A. So both are same. Okay, you can understand both the way. This is just a notation how to represent that relation. Okay, so mathematically we are representing in this way, or you can understand, you can represent in this way also. Okay, or this way also, right? The real world example, you can see the friendship in Facebook, right? So if A is a friend of B, if A is a friend of B, then B is also friend of A, right? So this is the best example, right? See, friendship will not happen in one direction, right? If A is a friend of B, then B is also a friend of A, right? Fine. Now we will understand, I told you that I will explain about this particular definition, okay, later. So this is the right time to understand. In this definition, I had mentioned one thing called set of vertices. Okay, so let's read it. A graph is a data structure that contains a set of vertices, that means node, and set of edges that connects a pairs of vertices. So what is the meaning of set of vertices? Set of edges. This you might have learned about set in mathematics, okay, set theory. So I'm going to make use of that thing, how to represent in a set theory form. Okay, the graph. See, this picture you can't store inside a computer, right? So you have to represent in the mathematical notation, so that computer can, or as a computer can understand it, right? So how can we write it? So let's see. So if I want to represent vertices, so I will write like this. Vertices I represent with V. Then I will take a set, right? Set is represented by curly braces. Then what are the vertices here? A, you can see B, C, and D, right? These are all vertices, right? Now if I want to represent edges, that is E. Okay, so you understood how I written these vertices, right? Now this is a set, right? Because it's a curly braces. And what is the definition of set? It should contain a distinct value, right? So all these A, B, C, D are distinct value, right? And it should be unordered. See, it should be unordered in nature. It's not that see, this is a definition. It should be distinct value, distinct values. So of course there are distinct values are there, and it can be unordered also, unordered in nature. Okay, so elements can be unordered. How? See, even if I can mention like this, V equal to B, A, C, or D, anything. If it is, if the vertices are numbered, okay, then I can write like this: 1, 2, 3, 4, 5, or if I can even mention 2, 1, 4, 3, 5, right? So it should not be in a ordered pair, or it should not be always in ordered pair. It can be unordered. That is the definition of set, right? So here I mention ordered, that doesn't mean it can be unordered, right? Okay, now let's see the edge set. Okay, how to write a edge set, which is denoting by E, capital E. Then edge set is the relation between that particular nodes, right? So how can I write it? A related to B, right? So take this first particular node and try to see all the relation. So A is related to B, so you write it in a round bracket inside it. After that, A is related to C also, so write like this, right? A is related to D, so A is related to D, right? So write like this. So you take one more node and see the relation. Now you check for B's relation. Okay, so B is related to A, but we are already mentioned here A related to B. So you don't have to mention again A, B related to A. Why? Because of undirected rules, right? If A is related to B, then you don't have to mention B related to A. Both are equivalent. So either any one of them you write inside the set. Okay, both are equivalent only because this is the undirected graph, right? So B related to A, I don't have to mention. Is B related to C? No, B is not related to C. B related to D? Yes, I can write this, right? Now come to C. Now C related to A. C related to A. Should I mention C related to A? Because A related to C is already there. Then I don't have to mention this. So C related to B, there is no connection. C related to D, yes. This is a new one, new relation. So you can mention it, right? Now take the D node and see the relation. Now you try to see D related to A. So D related to A, if I mention, so let's check whether A related to D is already there. Yes, already there. Then you don't have to mention it. D related to C, D related to C. So let's check whether C related to D is already there. C related to D, yeah, already there. Then you don't have to mention. Now D related to B. So check whether B related to D is already there. Yes, already there. If it is already there, then you don't have to mention it, right? So that's it. That is the edge set. Okay, so you have to remember this. You should not write both this set. Okay, if either you write A related to B or B related to A inside this edge set. Okay, because the set, I'm talking about set, and set should not have any duplicate values. Any, because of this rule, they both are considered equivalent. So if you write both the thing, then it will be considered as equal only, and it will consider as a duplicate value. Okay, it should have a distinct value. So that is the thing of edge set. Okay. Okay, let's see a directed graph. So in a directed graph, you can clearly see that in which edges have direction. Okay, you can see the example here. This is an example of directed graphs. Both are directed graphs. Okay, I just changed the value of the node here. Here I represent using a alphabets. Here I'm representing using a numbers. Okay, integers. So both are okay. Okay, both are graphs, so that I can explain you okay even better. That's why. So both represented graphs. Okay, and this is possible. Now what is this notation means? This U and V's both are vertices. Okay, it represents a vertices. So what is the meaning of this is, for example, C, I had written here, if A is connected to B, it doesn't mean that B is also connected to A. Okay, in directed graph, right? So what does it mean is, if A is connected to B, okay, it doesn't mean that B is also connected to A. That is how it is written here. Okay, or another way to write is, if A is connected to B, doesn't mean that B is also connected to A, right? So you can write like this in both the way. Fine. So that is directed graph. So you can understand with one example also. For example, Instagram followers. In Instagram we have something called follow, right? So if A follows B doesn't mean B follows A. For example, A is a Ramesh. So if Ramesh follows Narendra Modi, it doesn't mean that Narendra Modi will also follow Ramesh, right? Okay, so same thing. So it represents this follow thing. So you can understand with real example also. Fine. Okay, now let's take an example of this graph, and I represent the vertices for this graph. Okay, so V for vertices, right? So 1 2 3 4, I can write a set of vertices, right? It can be in unordered fashion also, like 2 1 3 4, okay, or 3 1 2 4, any order. Okay, it doesn't matter, okay, because it's a set. Okay, I explained all this part. Now how to represent edges, right? For that you have to understand something called connection to represent edge set. Okay, this is also a set, right? To represent this you have to understand the connection also, right? So how can you establish a connection here? See, I already told you. Can you see this arrow here? Okay, this arrow is called outgoing edges. Okay, for example, when you're standing here, okay, and when you look at this arrow is going outside. Okay, this arrow is going outside this node, right? So this is called outgoing edges. This is called outgoing edges. I'm written here, outgoing edges. Okay, and when you're standing here, you can see this arrow is coming towards you, right? This arrow is coming towards you. This is called incoming edges. When arrow is coming towards you, when you're standing at this node, an arrow is coming towards you, this is called incoming edges. Okay, so I written here incoming edges, right? Outgoing edges and incoming edges, right? Now why you have to understand about this is because outgoing edges represent a relation, that someone is connected, you are connecting with someone, that is represented by outgoing edges, and incoming edges represent that someone is connected with you, right? Right, I had written this part here so you can understand. Outgoing edges represent that we are connected with someone, and incoming edges represent that someone is connected with you, right? Okay, we will take one example, you will understand. For example, you take this part only. For example, one is connected to you take this here, 1 is related to B. So if 1 is related to B, how can I represent? I will represent like this, right? Outgoing edges. In this edge, I will represent like this. 1 is related to B. Okay. Then if I want to see that 2, if I want to say that 2 is also related to 1, if 2 is also related to 1 or 2 is related to 1, how can I represent it in the graph? Then I will represent like this, 1 and 2 is there. Then there would be outgoing edges from 2, right? And this represent 1 is related to 2. So looking at the outgoing edges, you can clearly see. So if I want to, that 1 is related to 2, and this means 2 is related to 1. 1 is related to 2, right? Here 1 is related to 2, but 2 is not related to 1. Here 2 is related to 1 because there is an outgoing edges, but 1 is not related to 2. So you can clearly see that 1 is connected to 2, but okay, so I hope you understood, right? So keeping that thing in mind, you can understand one thing here. You can establish a connection here also. So if you are standing here, okay, you are observing this particular node, so you can see that 1 is connected to 2, 1 is connected to 4, and 1 is connected to 3, right? Now if you look at 2, because this is outgoing edges, right? Outgoing edges, you can see, if you want to understand what is outgoing edges, see, when you're standing here, there is an open, that mouth is open towards that particular node, and incoming edges means this mouth is pointed towards that particular node, right? Now if you're standing here, then you can clearly see that's there are two incoming edges, right? So that means someone is connected to 2, but 2 is not connected to anyone, right? So this is what this is how a directed graph establishes the relation, okay, or shows the relation between the two nodes, right? Now you have to identify how many number of incoming edges are there and how many number of outgoing edges are there. So how can you understand? So if you look at the one, how many number of incoming edges are there? Or how many number of outgoing? Is there any incoming edges here? So I will represent using okay, I will take one more color. I will take incoming edges I will represent with I, and outgoing edges I will represent with O. Okay, so let's say how many incoming edges are there for 1? 0. There is no incoming edges. How many outgoing edges there for 0? There for 1? You can see 1, 2, 3. So clearly it is 3, right? Now here also let's see incoming edges and outgoing edges. So for 2, how many incoming edges are there? You can clearly see there are 2 incoming edges, right? This and this. It is incoming edges. So 2. And how many outgoing edges are there for 2? Outgoing edges. Outgoing means it will be like this. There is no outgoing edges. So it is 0. Right? Similarly, for here I and 0. So how many incoming edges are there? For 3. So incoming edges, you can see, yeah, this is incoming edges. Okay, is any other incoming edge? No. So 1. And here how many outgoing edges are there? This is outgoing edges, right? For 3, this is outgoing edge. So you can clearly see there is 1. Right. Now for for 4, how many incoming and outgoing edges are there? For you can clearly see incoming edges are, okay, this is incoming edge, right? Any other incoming? Yeah, this is also. So you can clearly see it is 2. And outgoing edges, for this outgoing edges are there. For 4, this is the outgoing edge. The outgoing edges is, this is 2, this is 1. Right. So this is how you identify all this thing, right? Okay, hope you understood. Now we will try to define this edge set. So you understood about incoming and outgoing edges. So with this we will try to define this edge set. This is remaining, right? So still it is blank, right? So how can you define a edge set? Now you understood all these things, so it would be easy for you. Now for 1, for the try to see the relation for this 1, node 1. So 1 is related to 2, right? So I can write like this, because outgoing edge, right? 1 is related to 3, right? 1 is related to 3. Can you see? So I can write 1 by 3. And you can clearly see 1 is related to 4 also. So I can write 1 by 4. Fine. So all the relation with 1 is over. Now let's see for 2. What is the relation? Okay, so look at the outgoing edges for 2. So is there any outgoing edges? No. So there is no connection, right? No relation. 2 is not connected to anyone. Someone else is connected to 2, but not 2. Now let's see for 3. Is 3 is connected to some other node? Yes. You can clearly see 3 is connected to 4. So you can mention here 3 is connected to 4. Right. Now is any other connection? No. Now what about the 4? Let's see, is 4 connected to anything? Yes, 4 is connected to 2. So you can mention that thing. 4 is connected to 2. Now you can complete this edge set. Right. So this is how you mention the connection, you edge set, right? So vertexes are also there and edge set is also there, right? So wherever this outgoing edges is, according to that you develop this particular edge set, right? So both the way is not possible, that's why I had written here that this particular directed graph shows the one-way correction. Okay, it will not show both the way of connection. And if it is an undirected graph, then it will show the connection between both the way. Okay, if A is connected to B, okay, if it is an undirected graph, then you will directly write like this, right? If A is connected to B, then B will also be connected to A. But it is a directed graph, then if A is connected to B, then B may not be connected to A. Fine. So that is the thing.